Hello academics around the globe, welcome back to Caltex Academy. Today in this video we are looking at episode number 3 of trigonometry, and specifically we are looking at how to calculate a missing angle and also a missing side in a right angle triangle. So let's take a look at our first question. So I've prepared 3 questions for you, so stick up to the end of this video because the last one looks interesting. So in our number 1, it says, in a right angle triangle, ABC, right angle at C, side AC equals 6 cm and BC equals 8 cm. Find the length of the hypotenuse AB. And secondly, the size of angle A correct to 1 decimal place. So we can do some small sketch of this triangle with the vertices A, B, and C. Now let's pick some line here to make this sketch. We will have it look like this, and we can draw 90 at C. Let's also drop this one, and we have this at 90 here. Yeah, so let's start meaning that we are told that at C is where our 90 degrees is. So let's go ahead and do that. Now we can pick a different color and have C here, and we have A here, B somewhere here. Now we can see AC is 6 centimeters. So let's name it here as 6 centimeters. The next one is BC. BC is 8 centimeters. Therefore, the main aim for the first question here is to calculate the hypotenuse AB. And since we don't know any of these angles here, then we can go ahead and use Pythagoras theorem to get this missing side here. So from Pythagoras theorem, our AB, by the way, we are answering part A of this question. So AB square is given by the sum of the square of AC and the square of BC. So from here, we can make substitution where our AB square is equivalent to AC, that is 6 centimeter, and of course we have to square, plus BC is 8 centimeter square. You can also work without the units, it's totally accepted. Now, when we square 6, we get 36, and the square of centimeter is also centimeter square. So squaring 8, we get 64. Also squaring this centimeter, we get centimeter square. So let's add them together, and we have AB square is equivalent to 100 square centimeter. But our main interest is to get only AB. So therefore, we have our AB is the same as taking a square root on all these two sides, and we have here 100 square centimeter and the square root, and the square root of 100 is 10. Meanwhile, the square root of centimeter square is centimeter, and that becomes our answer for part A of the question. Now let's move on to part B of the questions and say we are also to find the size of angle A. Our angle A is here, and we can go on and indicate angle A with maybe a letter theta, and we have that. So how do you get this angle theta? We have 3 choices to get this. One, you can use sine, the second one you can use cosine, and lastly you can use tangent. So I'm going to show you how to get them in all these 3. So firstly, looking at what has been given from the question here, we have here adjacent to this angle theta, and this is opposite. So the trig ratios that link opposite and adjacent is tan. So here we can take part B to be tan of any given angle theta is calculated from opposite over adjacent. So from here we can make substitution of our opposite as 8 centimeter over adjacent is 6 centimeter, and we know that these centimeters we just have to cancel off. Therefore, to get this angle theta, we can get the inverse and say tan arc of our 8 over 6. So let's get our calculator and work this one out to get the answer. Therefore, we have to get this arc off, we will come here, it is in the second function. So we have to punch, shift, and press also tan. and enter in our 8 over 6, and the denominator is smaller than the numerator, still we will get our results without problem. But for cosine, the numerator is more than the denominator, then it's not possible because of the restriction, the maximum of 1 or -1 for sine and cosine. But for tangent, it's not restricted. So therefore, our result is 53.13010. And remember, we are told to make it in one decimal place, so we can round off to one decimal place. From here, we pass to one decimal place, and that is our answer, 53.1. So let's place our answer here. Theta is equivalent to 53.1 degrees, and that is the result. What if somebody used a different approach here to get this angle? Obviously, the result we have just gotten here, because we know that the hypotenuse AB is already 10 centimeter. We can use opposite and hypotenuse, and that is sine. So sine of that angle theta is given by opposite O over hypotenuse H. So when we make substitution, we'll have sine theta is equivalent to opposite, that is 8. This time we're working without the units, over hypotenuse, and that is 10. So this is equivalent to arc sine of our 8 over 10. So again, we can get our calculator and punch that into our calculator to get the same result. So second function, sine of the angle. So we have here over 10, closing up this bracket, and this must give us 53.1 as before. Therefore, our result is 53.1. Since we've already rounded our calculator to one decimal place, it will just give us exactly. So if I've taken AC and AB, the precursor here would be cosine. So let's also do that to find out whether we will get the same result. And let's have cosine of that angle theta is given by adjacent over hypotenuse. So our adjacent, for our case here, cosine of theta is given by the adjacent is 6 and hypotenuse is 10. Now, getting theta alone, we get cos inverse of 6 over 10. Again, getting our calculator here, and we punch in second function, cosine of 6 divided by 10, closing up this bracket, and this must give us the same result, 53.1. So we can also write here 53.1 degrees. This results, and that only works well if you are sure that the hypotenuse is well calculated here. The moment you make a mistake from this hypotenuse, then the results for using sine and cosine will definitely be affected. So you just need to be careful. For the first one here, we use those original numbers 6 and 8, and our results are completely unaffected here. So let's move on and look at question number 2. Alright, in question number 2, it says a ladder leans against a vertical wall. The ladder is 10 meters long and the foot of the ladder is 6 meters from the wall. Find the height of the wall where the ladder touches. And the second part is the angle the ladder makes with the ground, break to one decimal place. So let's also draw our ladder here and see how it looks like. Now here, let's assume that this is the wall, and here we will also need to take the ground down here, and we also need to take our ladder, and this time I want to make my ladder looks somehow bigger like that. This is my ladder leaning against the wall. So for it to look like a wall, I need to design something here, and maybe we assume that these are bricks. So if these are bricks, make sure that it appears like a wall, and do something like that. These are the bricks representing our wall. Here, I think definitely this one looks like a wall. Don't you think so? Yeah, I think this one looks like a wall. And here, this is 90 degrees to the ground. This is 90 degrees. So we have some angle here, theta, where this ladder touches the ground and here is touching the wall, because we are asked to find the angle at the end of the day the ladder makes with the ground. So we can call it theta. Now, let's take a look. the ladder is 10 meters long. So this is 10 meters long, and the foot of the ladder is 6 meters from the wall. So if this is the foot of our ladder from the wall, that is what? 6 meters. So we have got 6 meters. Therefore, we can go on and get the height of this wall at exactly this point where the ladder is touching this. And from here, since we also don't know this angle, then we can use Pythagoras theorem to find out the height of our wall. H square, and here we're answering part A of the question, plus 6 square must give us 10 square. So when we square 6, we get 36. And this is equivalent to 10 square is 100. Now let's collect their terms. Remember, this is still square. So h square is the same as subtracting 36 from both sides. Here it will disappear, and we have h square is the same as 64. And getting square root on both sides, we'll have the square root of 64, and you know the square root always have two values, positive or negative, and the square root of h square is h, and here we have both positive and negative, 8, and since the unit here is meters, we also have here in meters, and remember the valid answer here is the positive one because it is just the length. So h is equivalent to 8 meters, and that is the height of the wall from the ground to where the ladder touches it. So that is how you answer part A of the question. And lastly, part B of the question is asking us to calculate the angle the ladder makes with the ground, and we have to connect it to one decimal place. Now, ignoring what I've just got in here, let me take adjacent and hypotenuse to make this calculation, and the three classes that links adjacent and hypotenuse is cos. So here we have cos of any angle theta is given by adjacent over hypotenuse. So from here, we can make substitution of our adjacent by 6 over hypotenuse 10. And as before, for us to get the angle theta, we get arc cos of our given values here, 6 over 10. Now getting our calculator, we can also punch in second function and cos of 6 over 10. Closing up this bracket and punching in our equal sign, the angle is exactly the same like in question number 1, that is 53.1. And let's look at the restrictions here. To what number of decimal places? Here we are told to get it to one decimal place. Therefore, our answer is valid to one decimal place, that is 53.1 degrees. And that is how we tackle question number 2. And finally, let's look at the last question. And before we go to question number 3, if you have not subscribed to the channel, go ahead and subscribe to the channel, share this video with a friend, and let's move on. Alright, question number 3 is right away here. In a right angle triangle PQR, the hypotenuse PQ is 15 centimeters and angle Q is 35 degrees. Find the lengths of sides PR and QR, correct two decimal places. So from here we can make some sketch, and from this sketch we will indicate these vertices according to the demand here. Alright, so let's draw our diagram like this, and from here we can drop another one to make at 90 degrees. We can estimate somewhere here, somehow down, and we join like that. So we make our 90 degrees here, and we can move on. Let's indicate this angle here, and that is at Q 35 degrees as indicated by the question here. This will be P and this will be R, where PQ is 15 centimeters being the hypotenuse. So we have here 15 centimeters. Therefore, what the question wants from us is the length of PR. PR is this side, and QR is here. And since we have this angle, then we can move on to get PR using the ratios that links the opposite and the hypotenuse. Therefore, sine of any angle, say also theta, is given by opposite O over hypotenuse. So our angle is 35 degrees, and this will be equivalent to our opposite is PR, what we are asked to find. Then hypotenuse is 15. And from here, we can go on and remove the denominator by multiplying both sides of this equation by 15. So let me recopy it here, and we have our PR over 15. Therefore, we can go ahead and multiply both sides by 15, and we have that 15 here. Therefore, this 15 we have to cancel, and we have PR is equivalent to 15 times sine of 35 degrees. Therefore, we can move on to get our calculator and punch everything into the calculator to see the results. And let's move this up here, and we have our 15 punch in, and we have sine of the angle 35 degrees. And first of all, look at if there's any restriction. Here, we have to correct to 2 decimal places. And remember, in our previous calculation, our result was in 1 decimal place, which is this one. For us to get to 2 decimal places, we can also fix it again here by coming to second function or shift, and you go to set up in order for us to identify 6. From 6, we punch in 6, and the calculator will ask us what number of decimal places do you want to fix your calculators. For this case, the question is asking us to make 2 decimal places, so we can punch in 2, and our result is 8.60. So we write it here, 8.60, and we take the unit of this length, and that is centimeter. That becomes the result for PR. So let's get cosine of any angle. Say theta is given by adjacent over hypotenuse. So we make substitution of the angle 35 degrees, and this must be equivalent to the adjacent, and our adjacent is what we are looking for, QR. So QR over hypotenuse is 15. We do the same technique like what I've done before. Cosine of 35 degrees should be equivalent to QR over 15, and we have to also multiply by 15. So let's say times 15. Oops, this color looks somehow done, but there's no problem about that. So we can cross this 15 off, and we're left with our QR, and I'll start writing our QR here, and we have this as 15 multiplies cosine of 35 degrees. So let's again get our calculator and punch it in, get our answer to 2 decimal places. So let's click this on it, and for us to be able to see clearly. Therefore, we have 15, and this multiplies cosine. You can go ahead and press multiplication sign, or just ignore the same thing. So you can press cosine of 35. And it's good practice to always close the bracket and punch in our equal sign. So the result is 12.29. Therefore, QR is the same as 12.29. And that is also centimeter. So we've gotten all our sides. Yeah, that is all. We have just finished answering our questions. So if you've enjoyed this video, please go ahead and give it a thumbs up, share with friends, and subscribe to the channel in order for you to get all the notifications, and see you in the next video. Peace out.